we're going to look at circles. You should be familiar with the circle shape. We're used to it as a wheel. We're going to look at the different parts of a circle. So let's start off with naming some of the sections. As you can see at the bottom of the screen, there are 1, 2, 3, 4, 5, 6, 7 different names to put in the 7 different places around your circle. Hopefully, you should know a couple of these already. You should know that diameter, it's not going to let me move it, is the full length of your circle from one side to the other. Diameter. You may know that radius is from the centre to the outside edge. If you have more than one radius, we call it radii. That would also be a radius. That would also be a radius. Any other version we want to put in would also be a radius. Then off of there. Now, you may also recall from your school days that the circle round the outside of the circle, what would be the perimeter in other shapes, is called a circumference. If it helps to think of it as a circle fence, try that. So, circumference. And that's this one. Now, some of the ones you may not be as familiar with. A line joining 2 points on a circle is known as a chord. A line that touches the edge of a circle at a point is called a tangent. Tangents are very useful, and you are going to come across them in triangle theory, trigonometry, as well as in circle theory. A tangent is always at a 90-degree angle from your radius on your circle. That's a useful fact we're going to be using later. Don't worry about it too much today. Let's clear some of this off. Right. Now, an area described between a chord and a circle. So this is maths language for you. The area between the chord and the circle, there, would be known as a segment. Now, often when we talk about segments, if you think about something like oranges, a segment would be a slice of orange at one piece, and that your instincts would tell you would be from the centre. That's not actually true. If it's from the centre, it's a sector. So that means this bit between the 2 radius lines, the 2 radii, this area is a sector. There's a few more that aren't on this yet. If we have a point and we go round to another point on the outside circle, we call that an arc. If it's a small one, we call it a minor arc. If it's a large one, the other side of the circle, all the way around to there, we call it the major arc. These are very useful when we get further into circle theory. At the moment, we're just dealing with the basic shape information. Right, so there's your basic diagram. Radius, diameter, tangent, chord, segment, circumference, and sector. These are the main ones we're going to use over the next week or two. Right. So here's your definition. A diameter, I shall start with circumference. The distance around the outside of a circle is called the circumference. The radius is the distance from the centre of the circle to the circumference, and the diameter is the distance across the whole of the circle through the circumference. That would make it 2 radii. So working out the circumference of a circle. Circumference of the circle, so that's the distance around the entire outside of the circle, the perimeter of the circle. And you find this by multiplying pi by the diameter of the circle. So the circumference equals pi times the diameter. Alternatively, because we know the diameter is 2 radii, we could say the circumference equals 2 pi r. So what is pi? Well, pi is a Greek symbol that is permanently used within mathematics to purely mean 3.14. It goes on forever, but for Nat 5 level, we can stop at 3.14. It is directly related to how many times the radii go around the outside of the circle. If you divide the circumference of your circle by 2, you will be out by 2 times your radius, sorry, you will be out by exactly 3.14 and a bit. For practical purposes, if you want to investigate why this is, how this is, there are plenty of YouTube videos you can watch on it, and I've got some links I can give you, but at this point, that would be more degree level maths than we're dealing with. At this point, we're just dealing with using the facts. If a circle has a diameter of 4, its diameter is 4, so it would be 4 times pi. That would tell us the circumference. If we know that its diameter, that its radius was 3, we would do 2 times 3 to get our number to multiply by pi. So let's have a go at this. We're dealing with circumference. In this first one here, we've been given the radius. So we're going to use C equals 2 pi r. I need a thinner pen. Okay, so we know our value of pi. We know our value of r as 120. So we're just going to substitute in and use a calculator to answer the question. Is the point. So we have C equals, I wanted that thinner way, 2 times pi times 120. 2 times 120 is 240 pi. Now, if you're working in a non-calculator paper and it doesn't ask you for a decimal answer, you can leave your answer as 240 pi. Unfortunately, it's not usually that easy. And we get an answer of 753.6. Now I'm going to change this equals to an approximately equals, because I've used 3.14 as my value of pi. If you use the full version, which is the pi button on your calculator, you would actually get 753.9822369. As you can see, it's a slight difference there. And we have the matching number. In the other cookie question, we've got the diameter, not the radius. So we can use the diameter formula. That is C equals pi d. The diameter is 6, so we have C equals 6 pi. And 6 pi, when we're using 3.14 for pi, gives us 18.84, which is what we expected. But as I say, that's a rounded answer. The actual answer using pi on your calculator is 18.849555592. These questions, when they come up in calculator papers, usually ask for rounding to a certain number of decimal places or for significant figures. Right. In your worksheets on Schoology, you will find this list of circumferences to have a go at. Feel free to do so in your own time. Any problems, remember to message me. So moving on to area. For the area of a circle, we're now using 2 dimensions. So we're going to have something that's squared. And as you can see here, we've got the area of a circle equals pi times the radius times the radius. So that's the area of a circle equals pi r squared. Not giving us a nice little one to practice on with that. Let me have a look. Nope. So we'll have to just try it with one of these. So, well, for the sake of picking one at random, I'm going to choose this one. And going to thin line. We have the formula A equals pi r squared. So we're going to replace our r with 25, square it, and times it by pi. For those of you that don't know you square numbers so high, like most of the population, that's 625. So A equals 625 pi. I'm going to times that by 3.14 for our value of pi, and we get 196.25. Now you're told it's centimetres. Because it's area, it's centimetres squared, centimetres in 2 dimensions. Now, let's have a look at the diameter question. I'm going to choose the first one. We've still got the same formula, A equals pi r squared. We've been given the diameter. We need the radius. So the first thing to do is find your r. R is half your d. half your diameter, so it's 15. This time it's millimeters. In questions that require you to do this, there's usually a point available just for finding your radius value. And let's substitute it in. So A equals pi 15 squared. 15 squared is 225. Pi is 3.14 for the purpose of these questions. So we have an answer. Area equals 706.5 millimeters squared. The same technique will work regardless of the numbers you use. Just remember, when you're converting at the end, to put your units squared. If you fancy doing a word search, there's one available on your worksheet. Thank you.